Ladies and gentlemen, I welcome you to our YouTube channel. My name is Professor Kevin. So please, if you haven't subscribed to our channel, please subscribe now and like our video and also share with your friends or your fellow learners. So on this video, we'll be talking about the derivatives of trigonometric function. So yeah, so before you watch this video, make sure that you watch the video that I uploaded of implicit differentiation and the rules of differentiation. So here you need to know the derivative of all our trigonometric functions. First, that's the first thing that you need to know. So I will start with the derivative of sine x. So the derivative of sine x is going to give us cos x. So you need to know that when you differentiate sine, you must get cos. And then when we differentiate cos, we get negative sine x. And then when we differentiate tan x, we get sec squared x. When you differentiate tan x, you must get sec squared x. And then when we differentiate cosec x, we must get negative cosec x multiplied by cot x. This is what we get when we differentiate cosec x. And then when we differentiate cot x, we are going to get negative cosec squared x. And then lastly, when we differentiate sec x, we are going to get sec x multiplied by tan x. This is what we get when you differentiate sec x. So you need to know the derivative of all these trigonometric functions. We have 6 of them. So you need to know all their derivative. So, and another thing, when we are differentiating the trigonometric function, you also have to multiply with the derivative of the angle. You also have to multiply with the derivative of the angle. So here, our angle in all our trig function, our angle it is x. So when we multiply with the derivative of x, it's like multiplying by 1 because the derivative of x it is the same as 1. So if we multiply it by 1, there's nothing that's going to change. It will remain the same. So you need to take that into consideration. So let's do some examples so that you can see what I'm talking about. So firstly, let's find the derivative of cos 3x. The derivative of cos 3x. So here we are going to say the derivative of cos. It is going to give us negative sine of an angle which is 3x. And then after that, we have to multiply with the derivative of our angle, and our angle in this case is 3x. So this thing is going to give the derivative of 3x is 3, so we're going to have minus 3 sine of 3x. So this is what we get when we differentiate cos 3x. So always remember to multiply with the derivative of the angle if it is not x, because when it's x only, there's no need for you to show that, because we know that the derivative of x it is the same as 1. So when you multiply it by 1, nothing is going to change. So let's go ahead and differentiate sine squared x. So the derivative of sine squared x. So here, sine squared x, it is still the same as sine x all squared. This still means the same thing. So we are going to apply chain rule. On the chain rule, we start by differentiating what we have inside. What we have outside. You start by differentiating what we have outside, and then you keep your inside the way it is. And then after that, you multiply with the derivative of what is inside. So let's apply it here. So it means I'll start by dropping our exponent, and then I write what I have inside the way it is. And then after that, I'm going to subtract 1 from our exponent. So if you subtract 1 from 2, we are still going to get 1. After that, you multiply by the derivative of what we have inside, which is sine x. Okay, so let me come and write it here. It will be 2 sine x multiplied by the derivative of sine x. So the derivative of sine x, we know that it is cos x. So we are going to have 2 sine x multiplied by cos x, and then this whole thing is going to give us sine 2x. This is a double angle identities. So it's very much simple. If you know the rules of differentiation, you are not going to struggle here, and also know the derivatives of all our trig function. So this thing, it applies in every trig function, whether it's tan or a cot or a cosec or a sec, we apply the same thing as long as that thing is a trig function. So here's a question. We have to find the derivative of y squared is equals to x squared plus sine of xy. So on this case, we are going to apply the implicit differentiation. We are going to use the implicit differentiation. So if you don't know the implicit differentiation, please go and watch the video that I just uploaded. So it's very much important to know the implicit differentiation. So in the implicit differentiation, we are going to differentiate every term that we have on our equation. So I'll start by differentiating y squared, and then again I go and differentiate x squared, plus I also differentiate sine of xy. So this is the steps that we use in implicit differentiation. So now let's find out the derivative of y squared. The derivative of y squared is going to give us 2y multiplied by the y over the x is equals to the derivative of x squared. We are going to get 2x plus, and then the derivative of sine, we are going to get cos, and then our angle there, it is xy. After differentiating any trig function, you also multiplies with the derivative of your angle, and then the derivative of that angle, it is xy. So we still have 2y multiplied by dy over the x is equals to 2x plus cos xy. Then here we are going to apply the product rule. We just keep the first function the way it is and differentiate the other function. If we differentiate y, we are going to get dy over the x plus, now we keep our second function, then differentiate the first function, which is x. So if we differentiate x, we get 1. So from here, we just need to simplify and make dy over the x to be the subject of our formula. That's what we need to do. So we have 2y multiplied by dy over the x is equals to 2x plus, if you multiply here, we're going to get x cos xy multiplied by dy over the x plus y cos xy. So now let's keep the one with dy over the x on the left hand side. And then after that, we will make dy over the x to be the subject of our formula. So let's also factor out with dy over the x. So if I factor out with dy over the x, I'm going to get 2y, the one that I have here, and then we are going to take this term to the left hand side. It will be minus x cos of xy. Don't forget we took dy over the x as a common factor. Then is equals to, we have 2x plus y cos xy. So now we are going to divide with everything that is close to dy over the x, and then we'll be having our final answer. So dy over the x there, it is going to be 2x plus y cos of xy, all this thing divided by 2y minus x cos of xy. So we are done differentiating this equation. So you must make sure that you understand the implicit differentiation and the rules of differentiation, then also know the derivative of all our trig function, then There's nothing much there. This thing is very simple if you follow the basic very well. So that's all. So let's do another one. So now we need to find the derivative of cosec sine sec x. So here we are going to apply the chain rule. We are going to apply chain rule. We start by differentiating what we have outside. So what we have outside is cosec. Then, so the derivative of cosec, it is going to give us negative cosec, our angle, which is sine sec x. Then it says the derivative of cosec must give us negative cosec angle multiplied by cot angle, and then the angle there I said is sine sec x. That is the angle. And then we are not done. We also multiply with the derivative of our angle, and then our angle we said is sine sec x. So this is the process. Then we are going to have negative cosec of sine sec x multiplied by cot of sine sec x. Then we multiply with the derivative of our angle. So let's find out what will be the derivative of sine sec x. So here we are still going to apply chain rule. We start by what we have outside. So the derivative of sine, we are going to get cos. So it is cos of our angle, which is sec x, because the angle of sine is sec x. So we differentiate sine, it will turn into cos, and then we keep the angle. And then after that, we differentiate our angle. Our angle is sec x. We go ahead and differentiate our angle. So now we'll be having our final answer is negative cosec of sine sec x multiplied by cot of sine sec x multiplied by cos of sec x multiplied by the derivative of sec x is going to give us sec x tan x. So this is the final answer. So this is how we apply the chain rule. So that's why I'm saying you need to know all the rules of differentiation and the implicit differentiation, and also the derivative of all our trig functions. So it's our next question. We have to differentiate square root of x multiplied by sine of root of x plus root of 2x. So here, if you can see, we are going to apply the product rule. So the product rule says that you can keep the first term the way it is and multiplies with the derivative of the second term. So if we differentiate sine, we're going to get cos. So our angle, it is still the same as x plus root of 2x. This is our angle. And then don't forget that when you differentiate the trig function, you also have to multiply with the derivative of your angle. So it means I will multiply with the derivative of our angle. We can write our angle in this fashion. It's x plus 2x to exponent 1 over 2. All this whole thing is on the same square root, so it's all in the exponent 1 over 2. Then plus, so now we are going to keep the second function the way it is, and then we differentiate the first functions, which is square root of x. So square root of x, I will write it as x to the exponent 1 over 2, because we cannot differentiate if it's not in the exponential form. Then now let's continue. So here we are still going to have root of x cos of, we are going to have root of x cos of root of x plus root of 2x. So multiplies by the derivative of that angle. So here we are going to apply the chain rule because we are differentiating x plus 2x exponent over 2 or the exponent over 2. So we're going to start by dropping this exponent 1 over 2 here, and then we write what we have inside the way it is. So it is x plus, I can still write this as square root of 2x, all, and then we are going to subtract 1 from our exponent, then we're going to get negative 1 over 2. Again, we are after, because don't forget here we apply the chain rule. It says that you differentiate what you have outside and then you keep your inside the way it is, and then you differentiate your inside after that. So now we are going to differentiate what we have inside, which is x plus 2x all to the exponent half. So if we differentiate x, we are going to get 1 plus, when you differentiate 2x all to the exponent 1 over 2. So let's come and do it here. We can keep 1 over 2 here, and then we keep what we have inside the way it is. So we subtract 1 from 1 over 2, then this is negative half if we subtract 1 from 1 over 2, and then we multiply with the derivative of what is inside, and then inside we have 2x. So the derivative of 2x is 2, right? Don't forget I was differentiating this one alone. So it means half multiplied by 2, it is going to give us 1. So it means we'll be left with this term only. So plus 2x all to the exponent negative half. That is what we're going to get. So that is all about the chain rule. Then plus this side, if this side we are going to differentiate x to the exponent 1 over 2. This one we're going to use power rule. It's simple, so we're going to keep 1 over 2. Then we'll be having x to the exponent negative 1 over 2 multiplied by sine of root of x plus root of 2x. This is what we have so far. And then let's rewrite these things in the positive exponent. So I'll be having square root of x cos of square root of x plus square root of 2x. Then again, this is going to be 1 over 2 square root of x plus square root of 2x. Then we are going to have 1 plus 1 over root of 2x plus, here we are going to have 1 over 2 root of x multiplied by sine of, or I can write sine here on our numerator. So it is sine of square root of x plus square root of 2x. So yeah, we can leave our final answer here, because the main thing is not to simplify more, but the main thing is to differentiate until there's nothing to differentiate anymore. That's when you can be able to get marks. In calculus, we must make sure that we differentiate until we have nothing to differentiate anymore. That's what we are fighting for. So we can leave our final answer here. So here it's our next question. We have to differentiate 1 over square root of sine squared 3x plus cos squared 3x. This is what you need to differentiate. So you have many ways to differentiate this. You can use quotient rule since it's in the form of a fraction, and you can also do it using chain rule. But firstly, if you are going to use chain rule, it means you must rewrite this as, let me rewrite it, the derivative of, we know that square root is the same as exponent half. So this is going to be sine squared 2x plus cos squared 3x all to the exponent negative 1 over 2. Because sine squared 2x plus cos squared 3x, they were on the denominator. So if you know the laws of exponent, you get what I'm saying. So now we can be able to apply the chain rule. Then let's start applying our chain rule. We're going to drop our exponent, which is negative 1 over 2. We keep what we have inside, there it is, and then from there we are going to subtract 1 from our exponent. So minus 1 over 2 minus 1, it is minus 3 over 2 multiplied by the derivative of our the derivative of what we have inside. Sorry, I wanted to multiply with the derivative of the exponent, I mean the derivative of the angle, before I can differentiate what we have inside. So it now goes process by process. So this is the chain rule that I just applied here. So we can still rewrite this as negative 1 over, here is going to have a positive exponent, it is sine squared 2x plus cos squared 3x, it's cos squared 3x, mistakenly like 2x, cos squared 3x, all the exponent 3 over 2, okay, multiply by, okay, let's find the derivative of sine squared 2x. I've talked about this when we started this video. I said sine squared here, because we're talking about sine squared 2x, is the same as sine 2x all squared. So we're going to apply chain rule. It means we start by dropping our exponent and then we write what we have inside, which is sine 2x. After that, we are going to differentiate what we have inside, which is sine 2x. So if you differentiate sine 2x, okay, firstly, when you differentiate sine, you get cos 2x, okay? Then after that, you differentiate the angle again. So our angle, if we differentiate it, we are going to get 2 because it is 2x. So this 2 sine 2x cos 2x is going to give us sine 4x. So I can come and write, I start with this 2 here. 2, then multiply by sine 4x plus, let's do the same with cos squared 2x. So I'm going to write cos 2x all squared. So we are going to drop our exponent of 2, then we keep what we have inside the way it is, which is cos 2x, and then we differentiate cos 2x. We're going to get negative sine 2x. Then we multiply with the derivative of our, oh, it's not 2x. I'm always making a mistake, it's 3x. Yeah, the angle is 3x, not 2x. Our angle is 3x. So, but all the processes are fine, just that I made a mistake with the angle. So, as I said, you drop the exponent and write what you have inside, which is cos 3x here. Then we differentiate what we have inside. If we differentiate cos 3x, we are going to get negative sine 3x and multiply with the derivative of the angle. So, it's going to be 3 because the derivative of 3x is 3. So, don't forget we have a negative. So, this first 3 times here, let me also write negative there because we're gonna have negative because of this negative side. So this 2 cos 3x sine 3x is going to give us sine 6x. This is a double angle identity. Then we still have 3 there, so I'll start with 3 sine 6x. So to make things short, we can end our solution here. Because we don't have like terms that we need to add or that we need to subtract. So the main aim here is to differentiate until there's nothing to differentiate anymore. That's all. Simplifying and stuff is not much important. So we are done with this one. So that's all. And then, oh, sorry, I forgot that here I forgot because we have negative 1 over 2. So here it will be 2. I wanted to forget that. Sorry, I hope you understand that too. So everything is clean and perfect. So let's do the last example and then it will be the end of our session. So here we have the last example where we're having we have to differentiate cube root of 3x sec x all over tan 2x. So here we have many or plenty ways to differentiate this one. So I'll just pick Since on the last example I used chain rule, so let me just use quotient rule on this one. So let's rewrite this in the exponential form. So we're gonna have 3x sec x all over tan 2x to the exponent 1 over 3. So now we can be able to differentiate this. But firstly, we are going to apply the chain rule, even though we're still going to apply quotient rule here. So we start by what we have outside. I'll drop the exponent 1 over 3. Then I keep what I have inside the way it is. 3x sec x over tan 2x to the exponent. We're going to subtract 1 from 1 over 3. Then we're going to get negative 2 over 3. And then we multiply with the derivative of what we have inside. Let me just come and apply the quotient rule. So I'm going to square my denominator. I think here we need a long fraction. So I'm going to square tan 2x. And then after squaring that denominator, come and write it here. And then you multiply with the derivative of what we have on the numerator, which is 3x sec x minus, we keep our numerator 3x sec x, then we differentiate what we have on the denominator, which is tan 2x. So let's find out what will be our answer. 1 over 3. Then this one can still be the same as tan 2x all over 3x sec x. Instead of exponent negative 2 over 3, it will be positive 2 over 3 logs of exponent. Then let's find out what will be the answer. We are going to have tan 2x multiplied by, okay, here 3x sec x, we have two functions, so it means we're gonna apply the product rule. Two functions are multiplying each other, so it's product rule. So 3, we can keep 3x and then we differentiate sec x. If we differentiate sec x, we are going to get sec x tan x plus, in this case we keep sec x and differentiate. We're going to differentiate the first function, which is 3x, so it's going to give us 3. So let's come and write it here. We are going to have 3x sec x tan x plus 3 sec x, then minus, here we are having 3x sec x. If we differentiate tan 2x, when we differentiate tan, we get sec squared. Our angle is 2x, and then we're still going to differentiate our angle, which is going to give us 2. The derivative of 2x is 2. Then we're having 2 sec squared 2x. So all we need to do from there is just to simplify these things, then that will be the final answer. So we are done differentiating. You need to simplify these things, then that will be your final answer. So as I said, the main thing is to know how to differentiate. Simplify is just algebra. So if you know how to differentiate, you are good, and make sure you have a good algebraical skills. So this will be the end of our session. Thanks for watching this video, and don't forget to like and share and also subscribe to our channel. Goodbye.